Monitoring and control systems allow dispatchers to monitor and, in some cases, control equipment at several substations in the distribution system. This allows power companies to maintain a reliable power system and spot potential problems early without manning every substation. Monitoring and control systems have been around for many years. The equipment that does the monitoring and controlling is changing, though. It's now possible to monitor and control a lot more components from one central location. Monitoring and control systems can be configured in many different ways. The one that we're going to look at is a SCADA system. SCADA stands for Supervisory Control and Data Acquisition. Supervisory control allows dispatchers to monitor the operating status of the entire system and, if necessary, make adjustments to the system. Although this particular SCADA system is computer-based, they can also be operated by switches and relays. Let's look at some of the features in this SCADA system. System dispatchers can have the SCADA system maintain voltage at preset levels, or they can manually override individual components at each location. Another feature of SCADA systems is alarm monitoring. For example, fire alarms, security alarms, and other warning indicators can show up on the screen as a flashing light. This means that dispatchers know instantly when an alarm occurs. This avoids sending out linemen unnecessarily to a remote location to track down the problem. Another feature offered by SCADA systems is data acquisition. At the touch of a button, it's possible to find out volts, watts, amps, and VARs at any substation. As well as telling us the present operating status of the system, SCADA systems also allow dispatchers to control individual components. Let's say that due to temporary increase in load, these feeders need boosting from 13.2 kV to 13.6 kV. We can do this by adjusting the taps on the substation tap-changing transformer. This number, next to the tap-changing transformer, tells us that the tap is now set at tap position number 10. To boost these feeders up to 13.6 kV, we must change the taps to a higher position. In this case, the taps will move from a high number to a lower number because the taps are left of neutral on the transformer. Let's do it and see what happens. Okay, if we look at the screen again, the tap number has now changed to 8. The feeder now indicates 13.6 kV, which verifies that voltage has been increased on the feeders.